Now we are going to start up with another cell, that is the fuel cell. So the fuel cell is again a typical of a same type, that it is a voltaic cell, but the difference here that here we are going to take gases and there will be a continuous supply of gases. So that means the reactants are not going to exhaust here. So what kind of like structure we have? We have a compartment in which we have, we have a, you can say container in which we have got a compartments. Compartments are made up of graphite and they are porous and they are going to act as electrode. This one is in an anode and next to it is cathode. Likewise, we have many electrodes. Between this electrode, the space is filled with an electrolyte, that is aqueous KOH. We also have an outlet pipe here for water because often you can say randomly the water is forming, so we need an outlet from where we can remove the water. So we have an outlet pipe here. Here we have an inlet pipe. From anode chamber we are going to add hydrogen, and from this side we are going to add oxygen. So let's say what kind of reaction are going to take place. So as we know that reaction starts with anode, right, and we know that oxidation occurs at anode. So what happened, this OH interact with this H2, so H2 interact with this OH negative of electrolyte, loses an electron, and after that it results in the formation of two water molecules. And likewise at cathode, what happens, this O2 is there, it is going to react with this water, they will gain electrons because there are 4H, so that means they are going to gain 4 electrons, we will balance afterwards and we are going to get 4 OH negative. So as a result, let's see an overall reaction. So let's add these two reactions. We see that this thing 2O now, because when we are adding them, we may have to make the number of electrons same. So as we see, there are 2 electrons and there are 4 electrons gaining. So we will multiply the whole equation with 2. So when we multiply the whole equation with 2, so that means it becomes 2H2, it becomes 4OH negative, this becomes 4 electron and this becomes 4H2. I'll remove this, right. So now just we'll write and we'll add them and we'll get an overall reaction. We are going to cancel the same terms. So as this is 4OH, this is 4OH, so they cancelled out, and similarly we have 2H2O and 4H2O, so that means this H2 is cancelled and this is left only as 2. So what is the overall reaction? It is 2H2 plus O2 gives us 2H2. So this kind of reaction is going to take up in the fuel cell. I think you got it. And you know that what is the advantage of using this fuel cell? It is eco-friendly, this continuous supply of gases, so it is a continuous source of energy, and although it has the high efficiency, and we can denote its efficiency with eta. We denote this efficiency with, this is called as eta, which is given by G over delta H into. So this is how you are going to explain the fuel cell.